Hello children, welcome to 9th Chemistry online classes. Chapter 3 Atoms and Molecules. Today we are going to study an important topic that is called mole concept, and we will learn Avogadro number or Avogadro constant. Mole concept. How do we interpret a chemical equation? So when we get one equation, how can we, or which are the informations, or what are the informations we get from that chemical equation? We'll take one example. 2H2 plus O2 gives 2H2O. You know that this is the equation for the formation of water molecule. 2H2 plus O2 gives 2H2O. So by looking this chemical equation, what are the informations? That is called this interpretation. Okay, what are the information or how we can explain this chemical equation? So by two ways we can explain, or by we get two informations from this chemical equation. We just see the first one. Two molecules of hydrogen combine with one molecule of oxygen to form two molecules of water. So very clear from this equation. See here, two molecules of hydrogen. H2. H2 means the hydrogen is a diatomic molecule. You know that hydrogen have only the existence in diatomic molecule. So here 2H2. So total how many hydrogen? 4 hydrogen atoms are there. But here 2 hydrogen molecule. 2 hydrogen molecule. So 2 molecules of hydrogen combine with 1 molecule of oxygen, because oxygen is also a diatomic molecule. So this is oxygen molecule. So 2 molecule of hydrogen combine with 1 molecule of oxygen to form how many molecules of water? 2 molecules of water. Clear? So I'm repeating once again. 2 molecules of hydrogen combine with 1 molecule of oxygen to form 2 molecules of water. So that is the way that we get from this thing we get from this equation. So we just think of another way. Here 4 U of hydrogen molecules combine with 32 U of oxygen molecules to form 36 U of water molecules. And what is this U means what? That is the unit of atomic mass. Okay, so here 4 U of hydrogen molecule means here two hydrogen molecules are there. So one hydrogen atom's mass is 1. So here total how many hydrogen atoms are there? 4 hydrogen atoms are there. Here 2 molecules of hydrogen. Okay, so 4 U of hydrogen molecule combined with this is oxygen O2. One oxygen mass is 16. So here O2 means that is 32 U of oxygen molecules to form 36 U of water molecules. See 32 U plus 4 U, that is 36 U. So 4 U of hydrogen molecule combined with 32 U of oxygen to form 36 U of water molecules. What is, children? These two ways. Then therefore we can characterize the quantity of a substance by its mass or by its number of molecules. It's very important, so please listen. So this, by getting this chemical equation, two way we can interpret. One way is what? By number of molecule. That is we saw this in the first case, number of molecule, 2 molecules of hydrogen with 1 molecule of oxygen to form 2 molecule of water. So we are saying 2 molecule, 1 molecule like numbers. Okay, so that is by number of molecule, or other way is by its mass. That is here 4u, that is mass, 4u of hydrogen molecule combined with 32u of oxygen to form 36u of water molecule. So these are the two ways of interpretation of a chemical equation. So therefore we can characterize the quantity, okay, the quantity of a substance by its mass or by its number of molecules. So in the two cases we are give importance to the quantity, okay, quantity by its mass or by its number of molecules. Then a chemical equation directly indicates the number of molecules participating in the reaction. But see children, by looking this chemical equation, it is very clear that we can directly indicates the number, two molecule of hydrogen, 1 molecule of oxygen, and we get 2 molecules of water. It is directly given, but mass is not given here. Okay, that we already know what is the mass of hydrogen, what is the mass of oxygen, then only we can calculate that mass, this 36. If one person don't know the mass of hydrogen or mass of oxygen, he cannot calculate the mass of 2 molecules of water. Okay, but from the chemical equation, by looking the number, that is okay, that is very clear, 2 molecule of hydrogen plus 1 molecule of oxygen to form 2 molecule of water. So that is easy. Okay, a chemical equation directly indicates the number of molecules participating in the reaction. Thus, it is convenient for us to refer to the number of substances in a chemical reaction as number of molecules or atoms. So that is easy by taking number of molecules or number of atoms. That is very easy because that is visible to us. By looking a chemical equation, that is visible. That is why we are taking this number of molecules. Okay, let us see what is the next slide. Now we see what is the concept of mole. So we studied that by taking number of molecules or atoms is convenient rather than their masses. So a new unit, mole, was introduced. Okay, so mole is a that is a quantity of number. That is a number. Mole is a number. Okay, so we'll just see the definition. Mole is a quantity in number that has a mass equal to the atomic or molecular mass of species. So that species may atoms or may molecules or may ions or may any particles. Okay, so any particles that are in any species, that is any atom or molecule, ion, anything, but we are considering that as a number. That quantity we are taking in a number, that in unit in gram. Okay children, so that is called mole. Another example I will tell, 1 dozen. 1 dozen means how many? 1 dozen means 12. That means 1 dozen eggs means 12 eggs. 1 dozen pencils mean 12 pencils. So the matter is anything. Is it anything, any substances? Is it an egg or a pencil or books or anything? But dozen means what? That number, 12 number. Same way, a pair. A pair means 12. Sorry, a pair means 2. So pair of pencil or chappal or shoe or anything, that means 2. Pair means 2. The same way, dozen means 12. And 1 gross. 1 gross, GROSS. 1 gross means 144 number. So that substance is anything, but that gross means 144. So the same way here, mole is also that kind of a number, quantity in number that has a mass equal to the atomic or molecular mass of species in gram. That species means may atoms or may molecules or may ions or may particles. And 1 mole of any substance. 1 mole means how much number? 6.022 into 10 power 23 number of particles. that number of particles, it may atoms, ions or molecules, any particles. But that number is this much, 6.022 into 10 power 23. This is called the Avogadro number or Avogadro constant, which is represented as Na. Okay, so that number, this mole is a quantity of number. So that number, that is 6.022 into 10 power 23, that number is called Avogadro number or Avogadro constant. That is a constant. So this name, this Avogadro number, that is named in honor of the Italian scientist Amedeo Avogadro. So that honor of that scientist, we given that constant, Avogadro constant. It is very, very important. Avogadro constant is 6.022 into 10 power 23. Then the mass of 1 mole of a substance is the same as that is atomic mass or molecular mass expressed in grams. That means 1 mole of substance or 1 mole of water. 1 mole of water, how much? 1 mole. So H2O. Okay, so here 2 hydrogen. So 1 mole of water contain how many numbers? 6.022 into 10 power 23 particles. Anything, water molecule or carbon dioxide. 1 mole of carbon dioxide contain how many? 6.022 into 10 power 23. Okay, so that is this line indicates the mass of 1 mole of a substance is the same as that is atomic mass or molecular mass expressed in grams. So we expressed that in gram. Then gram atomic mass of a substance. Atomic mass means mass of an atom. The atomic mass of a substance when expressed in grams is known as its gram atomic mass. So atomic mass of a substance expressed in gram, we can call it as gram atomic mass. And what is gram molecular mass? The molecular mass of a substance expressed in gram, it is known as gram molecular mass. Okay, so mole. So in this slide, it is important thing is what is the definition of mole. Okay, so mole is a quantity in number. Okay, that number is what? 6.022 into 10 power 23. Number of particles. Number of particles, anything, atom or ion or molecule or anything. That is the number of particles. And that constant or that number is called Avogadro number. Let us take some examples. The atomic mass of sulfur is 32 U. Gram atomic mass of sulfur is 32 gram. What is the difference of this? Atomic mass of sulfur is 32 U. Gram atomic mass of sulfur is 32 gram. See, what is atomic mass? Atomic mass is the mass of an atom. And here, which is the atom? Sulfur. And you know that the mass of sulfur is 32. And atomic mass, so we expressed that in U, that is atomic mass unit. So that is why we write here 32 U, because atomic mass. And when the same thing when we expressed in gram atomic mass, so we can write it as 32 gram. Got it, children? So atomic mass, we tell atomic mass of sulfur is 32 U, but gram atomic mass of sulfur is 32 gram. Same way, atomic mass of oxygen is 16. Atomic mass of oxygen is 16 U. And what is gram atomic mass of oxygen is 16 G. Okay, that is the difference. And next. Also, 32 U of sulfur has one atom of sulfur. Atomic mass of 32 U. 32 U means here only one sulfur atom. And what is the meaning of this 32 gram? 32 gram contain 1 mole. 1 mole. And 1 mole contain, you know what is that number, Avogadro number, that is what, 6.022 into 10 power 23. And here sulfur atoms. And when we are taking oxygen, there is 6.022, 1 mole oxygen contain 6.022 into 10 power 23 atoms of oxygen. So now we take one molecule. We can say that molecular mass of carbon dioxide is 44 U. Molecular mass, that how we got 44. See, carbon dioxide is CO2, and mass of carbon is 12 plus, here how many oxygens are there, 2 into, what is the mass of one oxygen, 16. Okay, so 16 into 2, 32, 32 plus 12, 32 plus 12, that is 44. So molecular mass, same like atomic mass, molecular mass of carbon dioxide is 44 U, and gram molecular mass of carbon dioxide is 44 gram. So understood the difference, what is this U and this G? Yes. But we know that in the case of chemical equation, mole is the measuring unit. Mole is the measuring unit. If when 44 gram or like that, when we are saying gram or kilogram, that is the measuring unit. So here in the chemistry, mole is also a measuring unit. Therefore, 1 mole, that is equal to 6.022 into 10 power 23 number. So that number, anything, any oxygen or carbon or anything, 1 mole means this is the number. That is the relative mass in grams. William Oswald introduced the word mole, which actually means a heap or a pile. Therefore, we consider a substance as a heap of atoms or molecules. Next, a quick review of how mole, Avogadro number and mass are related to each other. The same table you can see in your textbook page number 40. See, so first we will take 1 mole of carbon atom. 1 mole of carbon atom. 1 mole, anything, is it carbon or carbon dioxide or carbon monoxide or oxygen or anything, 1 mole means how many? 6.022 into 10 power 23 atoms of carbon. Next we are taking 1 mole of hydrogen. 1 mole means 6.022 into 10 power 23 atoms of hydrogen. Here 1 mole of any particle, atoms or molecules or ions, that means 6.022 into 10 power 23 number of that particle. Next, 1 mole of molecule means 6.022 into 10 power 23 numbers of molecules. Got it? So 1 mole means that is the number, same like 1 dozen. 1 dozen carbon means 12 number. 1 dozen hydrogen, that also contain 12. 1 dozen any particle, that also contain 12. That is the same way you think like that. Okay. 1 mole means this is the number, 6.022 into 10 power 23. Now is just to take this side also. 1 mole of carbon atom, you know that 12 gram of carbon atom, that is the mass. Okay, 1 mole of 1 carbon atom, what is the mass of carbon atom? 12 gram. So what is the mass? 12 gram of carbon atom. Next, 1 mole of hydrogen atom, mass of hydrogen is 1. So 1 gram of hydrogen atom. Next, 1 mole of any particle. So relative mass of those particles in grams. Okay, so any particle we can count it, or we can measure that value, okay, in grams. And 1 mole of molecule, that also molecular mass in grams. So 1 mole of molecule means carbon dioxide molecule or water molecule, anything. So we calculate that thing and we get that molecular mass in grams, same like water molecule. 1 mole of water molecule, what is the mass? 18 gram. Carbon dioxide 44 gram, same like that. Okay, so this concept, that is over, this mole concept, and the next class we'll do some problems related to this mole concept and Avogadro constant. Okay children, so thank you, all the best.